Hey guys, welcome back to another Mathin' with Coach Lynn. Today we're going to cover lesson 4.4 in our Tennessee Reveal math book. Begins on page 223. Lesson 4.4 covers rational numbers. The I can statement states, I can order rational numbers and understand that the absolute value of rational numbers shows their distance from zero. The learn section, recall that natural numbers are numbers in the set 1, 2, 3, 4, and continue on and on. The set of whole numbers includes that set of natural numbers along with the number 0. Integers are any numbers from the set that go to the negative direction and positive direction continuously without end. Any number that can be written as a fraction a over b, where a and b are both integers and not 0 for the denominator, is a rational number. A rational number can always be represented as a point on the number line. So rational numbers are all numbers, where integers are whole numbers in the positive or negative direction. Whole numbers are 0 and positive whole numbers. Natural numbers are whole numbers that start with 1 and go forward in the positive direction. So the learn section at the bottom of 223, graph rational numbers on the number line. Rational numbers and sets of rational numbers can be graphed on a horizontal or vertical number line. A set of rational numbers can be written using braces, such as shown here. To graph the rational number on a number line, place a dot at its location. So we have 2.25 written in orange. They put an orange dot here to represent it. A little bit past 2 and not quite to 2.5. 2.25 we know is the same as 2 1/4. We have negative 1 3/4. So we have negative 1, negative 2. Halfway between there would be negative 1.5. So between negative 1.5 and negative 2 falls our green dot for negative 1 3/4. And we have 0, which we know is right here in the middle, neither positive nor negative. Now let's look at example 1. Graph the set of rational numbers negative 1/5, negative 0.7, 2 3/5, and negative 1.8 on the number line. Find the integer boundaries of the set. So the values in the set lie between the integers negative 2, because our lowest value number is negative 1.8. So the next integer lower than that is negative 2. And we know integers are whole numbers that are positive or negative. And 3 is our high value integer, because our highest valued rational number in our set is 2 3/5. So the next integer higher than that is 3. So now we're going to graph the rational numbers. To graph the set, it's going to be helpful for us to change them all to fractions instead of decimals, or decimals instead of fractions, whichever we are more comfortable working with. So in this case, we're going to convert them from fractions to decimals. So negative 1/5, we know is 1/5 is the same as 2/10. So it's a negative 2/10. 2 3/5, as we said, we know 1/5 is 2/10, so 3/5 would be 6/10, because 2 times 3 is 6, and it's a positive 2.6. All right, so we're going to graph each value on a number line. We're going to label the point with the value of its original form. So we have negative 1.8. Each tick represents 2/10, or 0.2. So we have negative 1, negative 1.2, negative 1.4, negative 1.6, negative 1.8. Now we have negative 0.7, which is negative 0.2, negative 0.4, negative 0.6, negative 0.8. So negative 0.7 is going to fall between negative 0.6 and negative 0.8. Now we have negative 1/5, which we said can be represented as negative 0.2. So it'll fall on that first tick to the left of 0, negative 0.2. Now we have 2 3/5, which we said can be represented by 2.6, which is 2 6/10. So we have 2, 2.2, 2.4, 2.6, which is 2 3/5. Now at our check problem at the bottom of the page, we have a set of rational numbers, negative 1 7/10, which can be represented by negative 1.7. We have 1.5 and 2/5, which we said 1/5 is 0.2. So if we need 2/5, we're going to multiply that by 2. So 0.4 is 2/5. And then we have negative 0.6. So negative 1 7/10, we go to negative 1. And in this graph too, every tick represents 0.2 or 2/10. So negative 1, negative 1.2, negative 1.4, negative 1.6, negative 1.8. So we know negative 1.7 is going to fall between negative 1.6 and negative 1.8. So right there is where we're going to graph negative 1 7/10. Then we have negative 0.6. So negative 0.2, negative 0.4, negative 0.6. Our next number is 0.4, which is 2/5. So 0.2, 0.4. And then the last number we will graph on this number line is 1.5. So we have positive 1, 1.2, 1.4, 1.6. So between 1.4 and 1.6 will be 1.5. Now let's learn absolute value of rational numbers on page 225. The rational number 2.5 and negative 2.5 are each 2.5 units from 0, even though they are on opposite sides of 0. Numbers that are the same distance from 0 on a number line have the same absolute value. The absolute value of a rational number is the distance between the rational number and 0 on the number line. So we see here we have negative 2.5, which is 2.5 units from 0, and 2.5, which is also 2.5 units from 0. So the absolute value of 2.5 equals 2.5. We know the absolute value is always positive because it tells us the distance from 0, and we measure distance in positive values. So the absolute value of negative 2.5 is also 2.5 because it's 2.5 units from 0. Example 2, find absolute value of rational numbers. The lowest point in a certain cave has an elevation of negative 53.4 meters. If the cave entrance has an elevation of 0 meters, evaluate the absolute value of negative 53.4 to determine the number of the meters a hiker would descend to reach the lowest point. So first we're going to graph negative 53.4 on a number line. So we go to negative 50, we have negative 55. So we see each tick is 1 unit, so negative 51, negative 52, negative 53, negative 54. So we know negative 53.4 will fall between negative 53 and negative 54. So how many units from 0 is negative 53.4? Well, we know the distance from 0 is the absolute value of that number, and the absolute value is always positive. So it's just the positive form of negative 53.4, which is 53.4. So the hiker descended 53.4 meters in the cave. The check problem, the Miller family is having an in-ground pool installed. The deepest point will be negative 7.5 feet below the ground. If the ground has an elevation of 0 feet, evaluate the absolute value of negative 7.5 to determine the depth of the pool. Well, we know it's located at negative 9.75 in relation to the ground level, which is 0. So how far is the bottom of the pool from 0? Well, that's going to be the distance from 0, which is the absolute value of the number negative 9.75. So it is 9.75 feet from 0. Now let's learn to compare rational numbers on page 226. To compare two rational numbers, you can compare the signs as well as the magnitude or size of the numbers. If the signs are different, the positive rational number will always be the greater and the negative number will be the lesser. So in this situation, we're going to compare 1.5 and 1.2. Since the signs are different, the positive rational number, which is 1.5, is the greater number, and the negative rational number, negative 1.2, is the lesser value number. So 1.5 is greater than negative 1.2. If the signs of the two rational numbers are the same, you can graph the numbers on a number line to compare them. If the numbers are written in different forms, it may be helpful to graph the numbers in the same form, so either both as decimals or both as fractions. Greater numbers are graphed farther to the right on a number line. We know lesser values are graphed to the left of the number line. As we talked about in the previous lesson, left and less both start with L, so that helps us remember that numbers to the left of the number line are less. So we're going to compare negative 1.5 and negative 1.2. The signs are the same, so we can use a number line to help us compare. Negative 1.5 is further to the left than negative 1.2, so that means negative 1.5 is less than negative 1.2. We can also look at the magnitude of the numbers, and 1.5 is a greater number than 1.2, but since they are negative, that means it is actually a lesser number. So negative 1.5 is less than negative 1.2. Now let's look at example 3, compare rational numbers. Compare negative 0.51 and negative 12/25. So we're going to write the fraction as a decimal to compare them. Negative 12/25, 25 times 4 is 100, so 12 times 4 is 48, so that gives us 48 hundredths, so negative 0.48 is the equivalent to negative 12/25. Now we're going to graph the values on the number line. We see we have negative 0.50 right here, so we have negative 0.51 to the left of that, and negative 12/25, which is negative 0.48 to the right. So since negative 0.51 is more to the left, we know it is the lesser value, and negative 12/25 is to the right, so it is the greater value. So negative 0.51 is less than negative 12/25. We also can look at the magnitude of them. Since they're both negative, we'll look at the values. We have 0.48, 0.51. 0.51 is a higher magnitude number than 0.48, but in negatives, that makes it a lesser value number. Now let's look at our check problem. Compare negative 3/8 and negative 0.413. So first I'm going to change negative 3/8 to a decimal. So I'm going to do 3 divided by 8, since we know fractions are also division problems. So I can't put 8 into 3, so I have a 0. Now I'm going to add a decimal and add a 0. I have 30. 8 times 3 is 24. 30 minus 24 is 6. I'll bring down another 0. 8 times 7 is 56. So we have 60 minus 56. That'll leave me 4. I'll bring down another 0. 8 times 5 is 40. So 40 minus 40 is 0. So negative 3/8 is the same as negative 0.375. So when we look at them, the magnitude that is greater between two negative numbers is the lesser value. Negative 0.413, negative 0.375. Well, 413 is larger than 375, but since they're both negative, we know this is the lesser value. So negative 0.413 is less than negative 0.375. You could also write that as with the original form. Negative 0.413 is less than negative 3/8. Let's learn to order rational numbers on page 228. To order rational numbers, follow these steps. Step 1, write each number in the same form. Since there may be different denominators in the fractions, it will be easier to write all the numbers as decimals. Step 2, use the signs of the numbers, place value, or a number line to compare the numbers. Step 3, order the values from least to greatest or greatest to least. We'll do whichever one they ask us to do when we get to that point. So to order the set, 1/4, negative 0.375, negative 17/50, and 0.3, We're going to graph the numbers on the number line. The least value is farthest to the left, and the greater value is farther to the right. So we have negative 0.375, negative 17/50ths, which if we were to convert that to a decimal, 50 times 2 is 100, so 17 times 2 is 34, so that's 34 hundredths, so negative 0.34, negative 34 hundredths. Then we have 1/4, which 4 times 25 is 100, so 1 times 25, so 25 over 100, 25 hundredths, 0.25, and then we have 0.3. So the set of numbers from least to greatest is negative 0.375, negative 17/50ths, 1/4, and 0.3. And from greatest to least is 0.3, 1/4, negative 17/50ths, negative 0.375. Example 4, we're going to order the set of rational numbers. They want us to order the set negative 2.46, negative 2 and 22/25ths, and negative 2 and 1/10 from least to greatest. So they went ahead and told us which way they want us to order it. Step 1, we're going to write the mixed numbers as decimals. So negative 2.46 is already written as a decimal. Negative 2 and 22/25ths. Well, 25 times 4 is 100. So 22 times 4 is 88, so we have 88 hundredths. So negative 2.88. Negative 2 and 1/10 we can easily write as negative 2.1, which shows us negative 2 and 1/10. Now we're going to graph the numbers on a number line. We've got negative 22/25ths right here, which we know is the same as negative 2.88. So it's going to fall close to negative 2.90. And we have negative 2.85 here, so we know it's going to fall right here between them somewhere. Negative 2.46, we know will fall between negative 2.40 and negative 2.50, and we actually have a line here to represent negative 2.45, so it'll be a little bit past that, towards negative 2.50. And then negative 2 and 1/10, which we said is negative 2.1 as a decimal, will fall right there at negative 2.10. So the set of numbers from least to greatest is negative 2 and 22/25ths, negative 2.46, and negative 2 and 1/10. So our check problem at the bottom of the page, order the set 2.12, negative 2.1, 2 and 1/10, and negative 2 and 1/5 from least to greatest. So we're going to convert 2 and 1/10. We can easily do 2.1, negative 2 and 1/5. Well, 5 times 2 is 10, so 1 times 2 is 2, so we have 2/10, so negative 2.2. Now, the number with the highest magnitude of negative numbers is our least value, so we have negative 2.1 and negative 2.2. Well, 2.2 is greater than 2.1 if they were positive, but since they're both negative, it makes it lesser, so it's our first number from least to greatest, and then negative 2.1, and then we have 2 and 1/10, which is 2.1, and 2.12. So we look at those. 2 and 1/10 would be the same as 2.10, and we have 2.12. Since 12 is greater than 10, it will go first at 2.1 and then 2.12. So from least to greatest, writing them back in their original form, negative 2 and 1/5, negative 2.1, 2 and 1/10, and 2.12. Now let's work through some practice problems on page 231. Our first set of problems wants us to graph each set of rational numbers on a number line. Number 1, negative 0.9, negative 2.5, 0.25, and negative 3/4. So if we were to graph them on a number line, we're going to graph them from least to greatest. The least will be more to the left, the greatest will be more to the right. I'm just going to order them from least to greatest, and we see that we're going to convert them to decimals. So negative 2.5 we know can also be written as negative 2.5. Negative 3/4, we know 1/4 is 0.25, so 3/4 will be times 3, so 25 times 3 is 75. So negative 0.75. Now out of my negative numbers, the one with the highest magnitude is my lesser value. So 2.5 is greater than 0.9 or 0.75. So that with the negative symbols, that makes it the lesser value. So negative 2.5. And then we have 0.9 and 0.75. 0.9 has a higher magnitude, but since they're both negative again, it is our lesser value. So negative 0.9 followed by negative 0.75. And then our greatest value is our only positive number, 0.25. So then if I were to rewrite them with their original form, negative 2.5, negative 0.9, negative 3/4, and 0.25 in order from least to greatest. Now, Mammoth Cave in Kentucky has a minimum elevation of negative 124.1 meters. Suppose a hiker traveled to the bottom of the cave. How many meters did the hiker travel? Well, we know since we're talking about the distance that the hiker traveled, that it's going to have to be the absolute value of the number with the elevation. We know that it says that minimum elevation is negative 124.1. So if they hiked to that minimum elevation, we want to know the distance they hiked. So that's the absolute value of negative 124.1. We know absolute value is always the positive of whatever the number is inside there. And distance is always positive. So they traveled 124.1 meters in the cave. Now number 5, we want to fill in with less than, greater than, or equal to make the statement true. We have negative 0.24 is less than, greater than, or equal to negative 3/16. To solve this, I can set up my division problem, 3 divided by 16. And I stopped after I got to 0.187. Could have kept going, but I'm going to go ahead and stop there because the number I'm comparing to only has 2 decimal places. So I'm going to compare negative 0.24 to negative 0.187. I'm going to say it's negative 0.18. Since 18 is less than 24, that means the 24 has the higher magnitude, but since they're both negative, it will make her a lesser value. So negative 0.24 is less than negative 3/16. Now number 7, we have negative 4 and 4/25 and negative 4.16. Well, 25 times 4 is 100. So 4 times 4 is 16, so we have 16 hundredths. So we have negative 4 and 16 hundredths and negative 4 and 16 hundredths. So these two values are equal. Negative 4 and 4/25 is equal to negative 4.16. Number 9, we're going to order each set of rational numbers from least to greatest. We have negative 4.25, negative 4 7/10, which we can write as negative 4.70. Negative 4 3/20. 20 times 5 is 100, so 3 times 5 is 15, so 15 hundredths, negative 4.15. Now if we want to order them from least to greatest, they're all negative, but the highest magnitude number will be our least. So we have 4.7, 4.1, and 4.2. So 4.7 is our least, so negative 4 7/10. Now we have 4.125, 4.15. So 4.25, 4.15, 25 is greater than 15. So negative 4.25 is our next number. And then negative 4 3/20 is our greatest number in the set of rational numbers they gave us. All right, guys, I hope this information that we've learned about rational numbers as we worked through lesson 4.4 has been beneficial for you. Take what you've learned, move forward, and have a great day.